Okay, we are recording. Hello, beautiful people. So, we are going to really quick go over some stuff. I got a few questions. The main thing that a whole lot of people had questions about were the hypotheses and variables. So I am going to go over that once again to hopefully help you guys. So I'm going to go through both of the worksheets. I have, well, not the worksheets, one worksheet, and then I also have the experimental design thing up, and then I'm going to share it with you as I look through it. So hopefully the lab safety quiz and the lab equipment quizzes went really well. Keep in mind that on all quizzes and all assessments like that, you'll have multiple attempts. Well, not all of them, but all of them for this week anyway. You'll have multiple attempts. I think you have 3 on each one. So if you don't get it the first time around, try again, because you will be able to use your highest grade, which is awesome. So hopefully those quizzes went well. You also had the scientific method breakdown, super easy, hopefully. That was about the t-shirts, and all you have to do is read that little experiment and answer the questions. Hopefully that went well. If it did not, please let me know. Let me help you. Help me help you. Let me double check to make sure that there wasn't anything too difficult on that one. I already went through it, but I wanted to make sure. The scientific method breakdown, it's the one with the questions about the t-shirts. So all of it pretty much was about the paragraphs. If you just read the Mary's shirt solution, then you should have gotten it. You can actually go back and underline everything, all of the answers. All of the answers are in here. And actually somebody that submitted this actually went through and highlighted where they found the answers, which was amazing. Highly recommend you do that for me and you. But I don't think that there's anything too difficult on here, so I'm not going to go over it. But I am going to go over this hypothesis worksheet where it gave you a statement and you had to figure out the independent variable and the dependent variable. I'm not too concerned about you writing hypotheses right now because you'll get practice on that later. But actually, for the second page, the number 6 through number 10, those were already in the if-then statements, which is how hypotheses are written. So you didn't have to do anything. You just had to rewrite exactly what it was and identify the independent and dependent variable. So I'm going to start actually in an if-then statement because I want us to remember that hypotheses, hopefully you can hear me and watch me at the same time. Hypotheses are, did that just move? Okay, anyway. Hypotheses are written in a if something, then something, because something. That's how, ooh, that's backwards. Is that moving with me? That's kind of cool. So, hypotheses are written in an if, then, because fashion. And we already went through this. I'm so sorry that that's backwards. That's going to frustrate me. But we already went through this in class. And we know that after every if comes the independent variable. After every then comes the dependent variable. And after every because is our inference. Now, in this worksheet, it does not have any inferences. It's just if then. So, because you know this, you know the answers to a lot of them. So, if plants are watered, then growth height will increase. If plants are watered, so if plants are watered, independent variable would be the water that the plants receive. If plants are watered, then growth height will increase. Then growth height will increase. So you have what you're measuring. You remember the dependent variables have to be what you can measure. So your dependent variable would be the sentence that comes after then, which is growth height. Growth height will increase. So growth height is the variable that you're measuring, and that will be your dependent variable. And there's no because, so you don't have to do that. So that's the layout for those as far as the if-then statements with numbers 6 through 10. Now, numbers 1 through 5, those are written as questions. But the great thing about questions, especially these questions, you have the word effect. The word effect. This word, I'm so sorry that's backwards. That's, okay. This word will let you know what your independent variable is, because independent, I manipulate, I change something in order to see a result. So if I change something, I'm going to see an effect. What I change will have an effect on something else. So what effect does high temperature have on radish germination? That's number 1. What effect does high temperature have on radish germination? So high temperature would be your independent variable there, because it comes after the question, what effect does this thing, so what I'm manipulating, what effect does this thing that I'm changing have on something else? And you remember, dependent variable, dependent, so the dependent variable depends on what I'm changing. So that would be the effect. So what effect does high temperature have on radish germination? High temperature, in other words, has an effect on radish germination. So the high temperature, the thing that I can change, has an effect or changes, or that's something that you can measure, the radish germination. The radish germination is the effect of the temperature. That was a lot of the same words and a lot of gibberish, and I hope that you followed on that. Just understand that if anything follows the effect of, that is the independent variable. You just think about what you're changing. You think about what you're manipulating in order to see something else happen. So that can be the case with all of them. I'll go ahead and give you number 2 as well. It's super easy. What effect does studying with music have on student test scores? So, what effect does studying with music? So I am changing or manipulating students studying with music. So in that experiment, it would look like I would have students that are studying with music and students that are studying without music. And then what I'm measuring, the reason I needed those two, remember your control, the thing that has no independent variable in there, because you need to compare it. So you have your group with music, you have your group without music. That right there tells you your music is your independent variable. Has on student test scores. So that is your measurable thing. Okay, you can measure the student test scores. You just see what they got. And then you document that and put it in a chart and a graph, fun stuff. So what effect does studying with music have on student test scores? Studying with music comes after the word effect, and also that's what I'm changing in the experiment. And the student test scores is what is affected, and that is the dependent variable. I really hope that wasn't just a whole lot of gibberish. So I hope that clears some of that up. So let's go ahead to experimental design variables and groups. This one you had to drag what each thing was. So let me go ahead and share my screen. Okay, I hope that you guys can see this. I really hope you can. So let's go ahead and start this attempt. Okay, I want to do the ones with the 4. So let's go to the ones with the 4. Can I move? Yeah, let's go to the ones with the 4 options. Okay, so this one. A study was created to test the effects, ooh, that word again, effects of fear in children. The hypothesis of the experimenters was that if, keyword, if babies were exposed to fuzzy bunnies at the same time a loud cymbal was struck close behind them, then we see that if-then format, and we have effects. Look at that, all the keywords in one little paragraph. Then that child would be afraid of all fuzzy things. So let's go ahead and stop there. Okay, we have our hypothesis. The hypothesis of the experimenters was that if, keyword, if babies were exposed to fuzzy bunnies at the same time a loud cymbal was struck close behind them. So this is your experimental group right here. Okay, your babies were exposed to fuzzy bunnies at the same time a loud cymbal was struck close behind them. Okay, that right there is your experimental group. That is what you're looking at. That's what you're changing. Okay, so right there, you know that's your independent variable. Then that child, then keyword, that child would be afraid of all fuzzy things. That child would be afraid of all fuzzy things. So you know that that is your dependent variable. Okay, let's keep reading. Another group of children would be exposed to bunnies without any loud noises. Without any loud noises. You see the word without right there. That means that they took something away. What they took away was the independent variable. So you know that that group of children that were exposed to bunnies but with no loud noises, that group of children is your control group because you took the independent variable out. The study was carried out as planned, and as a result, hundreds of young children developed fear of all cute, furry bunny rabbits. That's so sad. Bunny rabbits are super cute, so that's a shame. So now that we have that information and we saw all of our keywords and we thought about what we are changing and what is changing as a result, we can go down here and go ahead and try this, okay? So response to bunnies. Right there, response is a part of dry mix, actually. Dry mix, some of the classes we had time to go over that, some of them we didn't. Dry mix is an acronym for dependent, responding, y-axis, manipulated, independent, x-axis. It's a nice little acronym for that, just to help you guys remember kind of which variables go on which axes whenever you're graphing stuff, and also it kind of helps you remember which variable does what. That's what the R and the M are for. So response is the R in dry mix, and that goes with a dependent variable. So as soon as you see the word response or responding to, you know that that is the dependent variable. So you can go ahead and pull that right on over because we see the word response, so I know that's dependent on something else. Now, let's go down here because played with bunnies with no symbol, we see that word no. And then this looks an awful lot like without loud noises, okay? No symbol without loud noises. And what did we say this was? We said that this was the control group right here. So played with bunnies with no symbol, that is the group of babies that were, that the independent, hold on. How annoying. This is the group that the independent variable was taken away, okay? The symbol is your independent variable right there, and that was taken away. So we know that because the independent variable was taken away, we can go ahead and put control group right there, okay? Now, I just said it, symbol or no symbol. We come up here, study the effects of fear in children. If babies were exposed to fuzzy bunnies at the same time a loud cymbal was struck close behind them. So if a loud cymbal was struck close behind them while they were playing with fuzzy bunnies, if a loud noise, there we go with the symbol, that right there is our independent variable. The symbol is our independent variable. So they could have a symbol or no symbol right here. That is what we are manipulating, okay? That's what we're manipulating. So what can we put there? Independent variable. Look at that. Look at that. Now, process of elimination. That makes this our experimental group. But let's go ahead and look at it. So we have our experimental group that played with bunnies with symbol because we are looking at this effect on their fear response. Okay. So this is the group that we are hoping to see a result from. This is the group that we are really going to collect that data from right here and compare it to our control group over here, okay? This has the independent variable existing in it. So this is our experimental group right here, okay? I really hope that that helps. Really hope that that helps. And the graphing one, I actually want to go ahead and just say this, even though on the graph, let's go back to the graph actually, the graphing one. Graphing. So you click on that, go ahead and we're going to go ahead and download that so that we can open it up and we can edit that. Boom, edit document. That's what you click right there, okay? I'm going to go ahead and open it in the desktop app because it makes it easier. Oh, look, the hypothesis worksheet. Okay, so this is your graphing right here. You don't have any pie graphs to chart, but you need to know what those are. Parts of a graph: title, independent variable, dependent variable, and scales. Please make sure that you have the correct scales for each, okay? All right, let's look at this first one here. Graph the following information in a bar graph. So hopefully you know what a bar graph looks like, and label and number the X and Y axes properly. Okay, so you have month and number of deer. So let's think about this. We know, you guys should know, based on kind of your math background, that usually you have your X right here and your Y right here in a chart that looks like that. So if this is your X and this is your Y, looking at dry mix, okay, looking at dry mix, ooh, I can draw in this? Learning something new every day. Draw. Let's draw. Oh, that's so annoying. Okay, so let's go ahead and draw. You guys remember the stuff that looked, oh, this is going to look terrible. Hopefully that looks familiar to you. I mean, not in that. What? Wow, that's so bad. Hopefully this looks familiar to you. So that's kind of the format that you're looking at here. But this is what I want to show you right here, okay? Dry mix. Dry mix is super important. Oh, that's so, yeah, we're going to have to fix that. Hold on a second. Woo, okay. I wonder if I can draw on it with my finger. Oh, that's better. Dry mix. I really want you to know about dry mix, okay? So the D right here is the dependent, okay? R is for responding, and then Y is Y-axis, okay? Now down here you have the mix. So M is manipulated. Ooh, that's bad, okay. And then the I is your independent variable, and then the X is your X-axis. So you have dry mix, dependent, responding, Y-axis, mix, manipulated, independent, X-axis. I sincerely apologize for how that looks. But this just helps you remember what they are and where they go. So now that we have this information, we know that this is X and this is Y. Let me make that so that, okay. So this is X and this is Y. So automatically based on this, we have X over here. So we know that that is the independent variable. Ugh, okay. This is just bad. We know that that is the independent variable. Y over here goes with dry, so we know that that is the dependent variable over here, okay? Now, if we didn't know that, we usually can just look at it and know, because you remember the whole thing, the dependent variable must be measurable. Usually it's numbers. Usually it's numbers. So there are your numbers right there. So you know that those have to be the dependent variable because they are measured. It is quantitative information. Hopefully you remember the words qualitative and quantitative from face-to-face day 2. So qualitative and quantitative. That's what that is right there. That is your quantitative data. Dependent variables must be measured. So that is your quantitative data. You know that that was measured, so you know that that's your dependent variable. Okay, so now that we have that out of the way, we know our independent variable is the month. We know our dependent variable is the number of deer. Now we have to give this graph an appropriate title. From your title, you should know exactly what you need, what that graph is about to tell you. So the wonderful word that you can use here is the word, boom, effect. We love that word in science, the effect of something. So give the graph an appropriate title. We know that what comes after effect is the independent variable. So the effect of the month of the year on the number of deer. Okay, if you put that you can't go wrong. All right, the effect of the independent variable on the dependent variable. You can never go wrong with that. It's perfect every time. So we can use the word effect to make a great title. So now that we have that, we have to make this graph. So we know that our dependent goes over here, in other words, your numbers, and then your independent goes down here. So if you don't mind, I'm going to erase all of this. I'll erase this stuff. There's got to be an easier way to do that. Okay. So over here we have our numbers, and then because that's our dependent variable with dry on the y-axis. Now let's look at this. We know for 100% certainty that we always start at 0 down here. We start at 0 down at the bottom. So I wonder if I can do a text box. I'm trying to think of the easiest way to do this. I feel like that'll be difficult. Maybe I can just draw the number. Ooh, this one's bad. Okay, anyway, we have 0 down here. 0. You always start at 0. Okay, now we have these little bitty notches up here, but I really want you to look at the numbers, okay? 12, 15, 20, 26, 32, 18. Now, I like right here that most of those, other than 15, is a nice even number, okay? But let's look at our graph to see if we can do 2s, because 2, like all of those are divisible by 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. We can fit them all in there. I like 2s. 2s are nice. They're very small, but you have all of those numbers right there that are divisible by 2 other than 15, but that's an easy fix. So 2, 4, 6, 8, 10. Let's just put like the important ones because that's a lot of writing and this is really hard to write with. So 10, 12, 14, 16, 18, 20. Whoa, that's big. Okay. Crap, where was 20? 12, 14, 16, 18, 20, 20, 22, 24, 26, 28, 30. Boom. There we go. We got our scale. That's very nice. Okay. Now, I'm only showing 10s, but we know that we went by 2s each time, okay? So that is beautiful. So now that we have that, we need to make sure that they're even. Yeah, we just counted all those out, so that's nice. Now we have our independent variable down here. So for a bar graph, you know that you're going to have big bars going up like this. So I'm going to do September. That's going to take up both of these because I like big chunky bars. They look nice. October. And then I'm going to skip one. November. I'm going to put it in for that one. November. December. That's so bad. That looks like doctor. December. January. And February. Yeah, I'm going to have to get better at that. Maybe I'll get a pen. So we have that. Now we need our labels. You remember you need labels, okay? You need labels for everything. Oh, it even tells you the X and the Y right here. I should have put dry mix in this. Anyway, you need labels. So over here, you already have the labels right here. Look at that. So right over here, we know that the X-axis is showing our number of deer. And down here, we know that these are months. Okay. Down here, we know that those are months. So now let's go ahead and insert our bars. September. September goes up to 38. This is our big one up here, okay? September. Whoa, why am I still drawing? Can we do that? Can we use the shape, please, now? I can't click. There we go. Okay, so we have our bar going all the way up to 38. I'm going to make this a color. It doesn't matter what color. Let's do blue. Okay, so we have this one going all the way up to 38. Let's make another one. Okay, let's make another one. Insert shapes. There we go. 32 for October. So let's go find 32. That's 30. This is 32. Ooh, that lined up nicely. Let's make that orange. Okay, let's do another one. Insert. Why can't I insert now? Anyway, insert shapes. Another one. November. November, we got 26. So this is our 20 mark. 2, 4, 6. And let's make that yellow. I mean, gray is like my favorite color, but yellow because we need to make this colorful. Look pretty, pretty. All right, December. We got 20. 20. There we go. Let's find that. Let's do another color. We already have blue. Let's do green. I really hope there's more colors. Oh well, I can make it a color. There we go. Okay, and let's insert again. For January, we got 15. Okay, so 15 is our weird number because we went by 2s. But we know that's an easy fix is we just go in the middle of stuff. So this is 10, 12, 14, and 16. This is where I want to be. I'm going to find the middle and bring it down. And there's my little bar. Let's fill with, I don't know. Let's do purple. Purple looks nice. Okay, so there's purple. And we got one more. One more. Okay. February, we got 12. We know that this is 10, and there's my 12. Let's fill it with, I don't know, what's the color we haven't done? We got red. We need red. Okay. Oh, and it's February. There's Valentine's Day in there. Perfect. Okay, that is a very nice looking graph. Okay. So it is missing the title, but I had it because you know, I just had to erase it so that I could do all this fancy stuff. So we have our graph. That is a very nice looking graph. Now we have to draw a conclusion. Now, conclusions. The main thing you need to remember about conclusions is that you can only use the data that you are given. So I don't care if you are a hunter and you know that September, right around where fall starts, that is mating season, okay? If you know that, you cannot say that the number of deer increases whenever it's mating season because that information is not given. We can only go off of the information that is given, okay? So our conclusion would be the number of deer is greatest in September and declines to February, okay? Declines through the months as we get to February. We can't mention temperature, we can't mention mating season, we can't mention any of that. We can only go based off of what data we have, okay? Now, that is our conclusion. However, if our conclusion does not support our hypothesis, whatever it was, then the because statement or our inference is what can change, and that is what can mention mating season or temperature, so on and so forth. So our hypothesis would look like our because statement anyway. Our inference would be that the number of deer is affected by the month of the year because it gets colder after September. There you go. There's your inference if you wanted to do it like that. But our conclusion for this would be that the number of deer is greatest in September and declines towards February. Okay, that's all I can say about this data because I don't know anything else. Okay, that's all we tested was the number of deer in the different months. Okay, and then you have a line graph down here, but again, you have your X and your Y. Make sure, okay, that you can get to 200. Make sure you can get to 200 with whatever scale you choose. And also make sure that you don't do 0, 2, 4. Okay, I have my 4. I'm going to do 16 right here. No, once you do that, you got to make sure that you do 2s all the way up. Okay, you can't skip around like that just to make it fit your data. So you might have to do 10s here. You might have to do 10s. I think there's only 20 lines, so you need to make sure that you can get to 200, okay? But hopefully that's a little bit easier, and make sure that whenever you do a line graph that you plot your data points first, and then you go back and you can connect the dots, okay? Make sure you connect them in order. Okay, that is all I got for you guys. If you have any more questions, please let me know. Remember, you have 4 ways to contact me: email, physically show up, you can text or call using my phone number, and you can use your mind. You can use your mind. You can also, I guess there's 5. You can also message me on Schoology using the little envelope icon. Wow, that word just escaped my brain. But hopefully this was helpful, and this will be every Friday. So we have like teacher work days Fridays. That's whenever we can kind of plan for the next week and stuff. And that is also when my office hours are. So if you need to reach me, you can do it then for sure. But this is going to be every Friday. So as we go throughout the week and you are working on your Schoology stuff for the week, then make sure you're coming up with questions so that you can ask me, and then I'll do a video like this and I'll upload it to Schoology so I can answer any of the questions